In this lesson, we'll look at how to apply security concepts to software development. Even though you may not be a software developer yourself, most security professionals work with software engineers in some capacity. Just like other company resources, the applications they develop need to be properly secured. Today, we'll look at the two most common development life cycles to understand how you can secure each step throughout the development process. The most widely used development model is the Waterfall Model. It's called this because each step is completed before the next step is begun. Each step flows to the next like a waterfall. The first step in a waterfall model is requirements. All requirements for the application need to be gathered from the client, user, or stakeholder. The next step is design. This is when the software is documented, diagrammed, and designed. After that, we have implementation. This is the actual coding and building of the application. We then have the testing phase. During this phase, a quality assurance team makes sure that the team met the requirements, that the code works properly across devices, and that security flaws and vulnerabilities were phased out. After testing comes the deployment. This is when the application is released to a client or the public. The final step is maintenance. The application is in use in this phase, but it's monitored for bugs or problems that are quickly patched. This is an ongoing state that continues throughout the life of the app. Understand that the application will likely go through some of these steps multiple times before moving on. For example, the application might go through the design step 5 times before it's ready to move on to the implementation step. Then the application may move from the implementation stage back to the design stage if a new feature needs to be added. This entire development cycle is a slow process and may take months or years to complete. The waterfall method lacks flexibility since the requirements determined in the beginning carry through to the end product. A more agile approach was introduced in 2001, which approaches software development as a continuous, changing process with never-ending versions, bug fixes, and enhancements. This approach is aptly named Agile. One reason the Agile methodology is pragmatic is because security vulnerabilities are constantly addressed with new updates and fixes. Unlike Waterfall, Agile doesn't work on the entire application at once. Instead, it breaks development into smaller timeframes called sprints. Each sprint has a specific duration, usually 2 to 3 weeks. Within this timeframe, developers work on a specific application feature. These features typically go through the same stages that all applications go through, such as requirements, design, development, testing, and deployment. At the end of the sprint, the developers move on to the next feature. With Agile, you perform testing throughout the development cycle to help catch security vulnerabilities early. Waterfall, on the other hand, leaves testing until the end of the cycle. This can cause testing time to be cut short to meet deadlines. Coding errors and design flaws are the main causes of software vulnerabilities. We can categorize these errors into 2 types: compile errors and runtime errors. A compile error refers to an error that occurs during the building or compilation stage. The error compromises the software implementation, which prevents it from running at all. A runtime refers to an error that occurs while the software is running. The software begins execution, but it fails when it cannot resolve a problem it encounters. During the coding and design phases, you can increase application security by integrating security testing into each step of the process. Let's look at 3 testing methods: static, dynamic, and interactive application security testing. Static application security testing, or SAST, is also known as white box testing. SAST focuses on analyzing source code, binaries, and bytecode early in the development process. SAST tools are good at identifying things like SQL injection vulnerabilities and buffer overflows. They can identify the exact cause of a coding problem, but only in code not yet deployed. They're language specific, but you can run them continually and apply them widely. Please note that they do have a high % of false positives and are limited in the types of vulnerabilities they can detect. Dynamic application security testing, or DAST, is also known as black box testing. DAST scans a deployed application once it enters runtime. The results are based on how the application responds to a series of tests from the outside. These tests aren't language specific and have a lower rate of false positives. The downsides to DASTs are that they're hard to automate, can't pinpoint the exact cause of a flaw, and can take up to a week to complete. Finally, we have interactive application security testing, or IAST, which can be broken down into two types, passive and active. In passive IAST, we build interactivity into static application security testing. IAST tools are source code scanners that work during runtime. In active IAST, the testing tools can access interpreters and compilers, allowing precise identification of a problematic line of code during runtime. This speeds up the testing and remediation process. The combination of passive and active IAST can help us in the development stage by catching vulnerabilities early, in the QA stage by adding automated security checkpoints, and in the production stage through continuous monitoring. That's it for this lesson. In this lesson, we reviewed two common software development life cycles, Waterfall and Agile. Then we looked at two different kinds of coding errors, compile errors and runtime errors. We finished up by looking at static, dynamic, and interactive application security testing and how these tools can help us secure applications throughout the development lifecycle.